Hello and welcome along to this special aviation webinar. Good afternoon or good morning or good evening, depending on where you may be watching. It's a special webinar on aviation, specifically on how high resolution wind data can reduce carbon dioxide emissions in flights. Welcome virtual, at least, to the Met Office headquarters. That is where we are hosting this next hour or so. That's in Exeter, in Devon, in the United Kingdom. My name's Alex Deakin. I'm your host, and I'm a weather presenter and meteorologist. I've been working for the Met Office for over 20 years. I know quite a bit about weather, but not very much about aviation. However, thankfully, we have some high-level experts who do know a lot about aviation, and they'll be doing the presenting and talking mostly through the rest of today. Before we get into that, though, a little bits of housekeeping. You are all on mute. The webinar is being recorded. However, you should be aware of that. That recording will be available to you afterwards. The webinar is going to be for an hour. And most importantly, although you are all muted, we do want you to contribute. We will have time at the end, 15 minutes or so, for questions. So please, at any point, if you have any questions, a query or anything like that, then please do just use the question facility, and we'll be going through those and have time at the end to go through them. Okay, so how does this next hour look? First of all, we'll be very proud to show you a little video which explains why we're here today, all about how our high resolution winds are helping to reduce carbon dioxide flights. And then we will have a couple of presentations from the Met Office about how the high resolution data works, its accuracy and its availability as well. Then we'll have a representative from AVTECH, the company behind the software that does all the hard work, and how they've partnered with the Met Office. And after these presentations, as I said, there'll be a time for questions at the end, where we'll be joined by Norwegian, who have been using the system. Okay, let's go through and see who is on the panel today. We have a few representatives. As I said, we've got Angus Fagernes from just outside Oslo. He's at the Norwegian HQ. He is a VP in sustainability at Norwegian. He's been responsible for developing the airline's environmental sustainability strategy in the midst of the pandemic. Before joining Norwegian, he advised companies on sustainability in Oslo and Brussels, mainly within the construction, energy, waste and finance sector. Anders is a student of economics and politics, educated at Copenhagen Business School, University of St Andrews and the Royal Norwegian Navy. From AVTECH, we have Nicholas Persson, who is coming from Stockholm, presenting from Stockholm today. He is Director and Marketing of Sales at AVTECH Sweden, has huge experience in the aviation industry, both operationally and from aviation IT development point of view. Has worked for more than 10 years for AVTECH in different roles, including software development, research, business management, and has also 15 years of operational experience from being a commercial airline pilot with experience of flying both Boeing and Airbus aircraft as well. And from the Met Office here, just about 10 meters away, I'm joined by John Dutton, who is Head of Transport at the Met Office. He is responsible for the Met Office's activities within aviation and the wider transport industries, with a background in applied meteorology at the University of Reading. He started his Met Office career as a forecaster, has been around the whole of the UK before moving on to customer relations and working directly with aviation customers to develop meteorological services. So that's who we've got speaking today and available for questions. So as again, just reiterate, if you do have any questions at any point, use the Q&A facility. Okay, why we're here, that's who's here. Let's talk about why we're here. We're very proud to be making this announcement today, and we've got a little video to show you which explains everything.
Winds can be used in flight planning to optimize the timing and efficiency of a flight. The current World Area Forecast System dataset provided by the UK Met Office and NOAA has approximately 9 minutes of flying time between each wind forecast point. But Met Office high-resolution weather forecast data is also available and uses high-performance computing power to generate a global high-resolution wind data service that reduces flying time to under a minute between each point. High-resolution weather data builds a much clearer picture of what is happening along an aircraft's planned flight path to inform more dynamic decision-making. This increased accuracy of wind information can reduce how much fuel is burned and how much CO2 is emitted during a flight. AVTECH is helping pilots optimize their flight profile using Met Office high-resolution wind data, resulting in less fuel being used. Using AVTECH's ClearPath software, Norwegian utilized Met Office high-resolution data across their Boeing 737 fleet to optimize their flights to ensure more fuel-efficient flight paths can be flown. At the start of the cruise phase, the pilot requests updated flight information based on the aircraft's flight plan from AVTECH via the flight management computer. AVTECH retrieve high-resolution weather data from the Met Office, and then, depending on the prevailing winds and aircraft performance, including analyzing the total weight, distance, altitude and speed, AVTECH ClearPath then calculates the most fuel-efficient altitude and provides the pilot with the optimum flight profile for their chosen route. This makes the flight more efficient in terms of time, cost, and the amount of CO2 emitted. AVTECH ClearPath, using high-resolution weather data, can reduce Norwegian CO2 emissions by an additional 10 to 15,000 tonnes per year, based on pre-COVID-19 air traffic levels. This CO2 saving is the equivalent to the same amount of greenhouse gas emissions from 31 million miles driven by an average passenger vehicle, which is approximately the same as driving to the moon and back 64 times. So if all airlines were to adopt a similar technology and, for example, air traffic levels were operating at 40% of pre-COVID-19 levels, around 496,000 tonnes of CO2 could be saved. And when air traffic levels rise once again to pre-COVID-19 levels, 1.24 million tonnes of CO2 could be saved by airlines. That's the equivalent of the amount of carbon absorbed by over 1.6 million acres of US forests in 1 year. With the Met Office's high-resolution wind data service, AVTECH's technology, and airlines like Norwegian utilizing this latest technology, the future of commercial aviation can be cleaner, faster, and more cost-efficient. For more information, visit metoffice.gov.uk/aviation green recovery.
Okay, so that's why we're here today. Now let's hear from some of our experts. First up, let's hand over to Jonathan Dutton from the Met Office, who will be talking through the Met Office's role in this new technology. Jonathan.
Okay, thanks, Alex, and hello to everyone, and thanks for joining us this afternoon. I just wanted to say a few words around the activities we have ongoing with regards to aviation sustainability, and talk through some of the ideas really in terms of how we think using weather information can help with efficiency and sustainability. So there are several areas of focus for us at the Met Office here for aviation. I mean, primarily, of course, it's around safety and ensuring all of the information that we provide has real good scientific integrity. And also it's based on robust systems, so we can deliver the information robustly and effectively. We've also done a lot of work over the last few years, of course, around performance as well. So certainly performance in terms of high capacity airspace, high capacity airports, and that linking also, of course, to efficiency. And further to that, of course, many links to efficiency in terms of fuel efficiency has a direct link to sustainability. And the areas of development we have to help achieve that really are twofold. The first of it is accuracy, i.e. how good is the amount of information that we can provide both in a short-term and long-term forecast sense. And of course, once we have lots of good information, how do we allow access and how do we enable access to that data? So they're the two big broad areas of development, and I'll try and talk through those a little bit more. As a Met Office also, we have a corporate target of being net zero by 2030, and we are very keen to extend our approach to net zero, if you like, to try and help the wider aviation industry to achieve the same approach. So from a sustainability perspective, then, we understand significant work is, of course, going on within the whole industry. So different types of fuel, new fuel types, new aircraft, airspace management approaches and so on, airspace organisation. But we also see that weather can act as an enabler to helping sustainability. And fundamentally, I suppose, for us, it's about how accurate data can be used, for example, in flight planning, flight optimisation and tactical rerouting. The crux of it, to some extent, in that sense, I think, is efficient routing leads to less fuel use and therefore a carbon saving. And one large area of activity for us, has just been shown in the video, is around a focus on winds. And some of you may be familiar with the WAFS system. That's a World Area Forecast System operated by ourselves and our colleagues over in the US. And that's where we are providing information, a global data set of information for wind temperatures and hazards on a 1.25 degree grid. So if you imagine a grid running over the horizontal grid over the whole globe, every 1.25 degrees is a grid point, and that corresponds to roughly every 140 kilometers over the world. That's the current provision. Now in 2023, we are moving up to a 0.25 degree grid. So that corresponds roughly to 27 kilometers. So it's a big step up in the amount of data we're providing and big step up in detail. And that's what we mean by higher resolution. We did a study on this, or a company called Helios did a study for us on the high resolution feed and the benefits that we think would provide. Now, these are pre-COVID figures, so we do need to adjust these, certainly to the right probably a bit, but by 2025, we're expecting a 792 million pounds saved per year globally by using the high resolution feed, and by 2030, 1,239 million saved per year globally. Now, this saving wasn't all about fuel efficiency. There were other parameters in there in terms of, for example, reduced injuries due to severe turbulence and so on. But the bulk of it certainly was around a fuel efficient approach and therefore a more sustainable approach in terms of using wind information. So that's what we're doing from a World Area Forecast System perspective. But our capability is higher than that from the Met Office here. We run a global model at 10 kilometers globally. Which again is another big step up in information available. And we're also trialing, for example, information at a much higher level of detail again. So, for example, a 300-meter limited area model we have been running in trial for some time now. So the amount of data we have available is significantly more and much more detailed than it has been before. So what does that look like? I mean, this is just a brief example really for winds at about 35,000 feet or so. On the left-hand side, you can see the lower resolution, the 1.25 degree feed. On the right-hand side, you can see the 0.25 degree feed. And hopefully on the right-hand side, you can see a much smoother picture versus a more pixelated, blocky picture on the left. Now, it's in that smoother image where we can hopefully pick out the detail that really enables that more efficient approach to the use of metadata. So really detailing where are the specific areas of favourable tailwind, for example, where are the strongest headwinds to avoid, where's the core of the jet stream, for example. So these details can be picked up much better, both horizontally and vertically, but also the information we have will be on a much more regular and frequent time step basis as well. So we're conscious also, of course, that sustainability and use of weather information with the sustainability focus is not just about the en route part of the flight, it's not just about winds as well. We recognise fundamentally also that predictability enables more confident decision making, both within air traffic management, airline and flight crew decision making. And that predictability comes from, of course, good quality and reliable met information. And the areas we anticipate, of course, that helps with are areas such as less airborne holding, for example, linking also to enhanced airport landing rate predictions, for example, in situations as low visibility or fog predictions. Getting those accurately correct helps with that more accurate and confident decision making around landing rates. Also, where, for example, we have thunderstorms or fog, forecast, then the predictability around that and the confidence in that prediction should enable a reduced discretionary fuel approach. As talked about previously, really in the video, we looked at improved strategic routing, and that's both from a wind sense, but also, for example, of having the predictability around the hazards, such as en route hazards, such as the lightning, the thunderstorms, CBs, icing, and turbulence. So improved confidence around that will hopefully enable more efficient routing to be performed at the flight planning stage. In turn, that should lead then to less tactical weather avoidance and the relatively expensive process of avoiding disruptive weather en route. Of course, where that does happen and there is some disruptive weather, then hopefully the meteorological information can enable in the short term to decide on the most efficient route to take in a tactical sense. So, for example, is it more efficient to climb by 2,000 feet or descend by, say, 5,000 feet to avoid an area of severe turbulence, or is it more efficient to take a route to the left or right to turn to avoid information tactically, to avoid hazards tactically? So all of these sort of information that we think we can provide increasingly in the future is really aimed to enable that efficiency of flight and therefore aid the approach to sustainability. An example of that really, I think, is shown in the images below, but from a predictability sense, from an aviation predictability perspective, there are two main considerations for us. And the first of those is accuracy. And by that, I think we mean the science and the modelling capability that allows us to provide information which is accurate and gives that confidence in the predictability. And the second aspect is resolution, as we've touched on, i.e. how detailed information we can provide. And the images shown there on the screen are an example of that. So on the left-hand side is a higher resolution turbulence image. On the right-hand side is a lower resolution turbulence image. And you can certainly see on the left-hand side, hopefully, much more detail picked up in terms of the areas of severe turbulence. Now, the idea of that is, of course, that with that available at the flight planning stage, a more efficient route can be selected early on to try and avoid severe turbulence, rather than a very late tactical change to the route, which could mean a large deviation from the planned route. Again, you can see in those images the lower resolution information is much more pixelated, much more blocky, versus the smoother image you can see on the left, which really represents that greater detail and greater granularity. So there are certain areas of focus for us from a science perspective, and how do we invest in R&D to help develop that predictability? And through the different phases of flight, say from the airport and TMA, the terminal maneuvering area, through the climb and descent, and through the cruise or en route phases, there are elements of weather information that we are working on from an R&D and accuracy perspective to continue to improve. So low visibility, of course, and disruptive strong wind events, crosswind events are well known to links to go-arounds and so on, and disruption at airports. And there's certainly areas of continual research for us. And at certain times of year, winter weather is still important. So focusing on how we forecast the rain and snow mix, the timing of snowfall and so on, and the timing of those hazards is key. And we continue to work on those areas. So, but moving outside of the airport and TMA areas, such as CB and thunderstorms, clearly that's a challenging area of predictability. Thunderstorms are notoriously difficult to pin down exactly where they'll be. So there's an element of forecasting R&D that we're working on, both in the short term, i.e. the tactical nowcasting sense, next few hours, through to the longer term and better predictability about where we expect thunderstorms to be, say in the next 6, 12, 18, 24 hours. And that applies, of course, to all phases of flight. And then as we move, just focusing, if you like, on the climb, descent and on the cruise and en route stages, there's been a lot of work undertaken so far within our icing and turbulence feeds, and also the wind and temperature. And much of that comes through in the new world area forecast system information that we are seeking to provide. So a large area of R&D underway and ongoing. And real help to that, I think, really is a recent investment you may be familiar with. So the UK government has invested in a large supercomputer investment here at the Met Office, and by 2022 we expect to have started to implement our next supercomputer. And that should give us roughly a 6 times the current capability. And in 5 years' time, at the next upgrade, that should give us an 18 times capability of our current computer. What does that mean, though, in the sense of what can we do with that? Effectively, it means we can model more information in more detail, but also it means we can run what we call ensemble modeling. And that's really where we take a model, we run it several times, and the outcome of that gives us a sense of the uncertainty or predictability of a certain situation, which of course can help in defining where the areas of greatest risk, for example, would be for the likes of en route thunderstorms or turbulence and so on. All of that computing capability and increasing computing capability is great, but underlying that is the science that goes into that. There's no sense in us, if like, providing a lot more detail unless it's good quality detail that we can provide. So underlying big computers is a lot of science R&D to make sure the quality and the accuracy is really good. Of course, we also recognise that us producing lots of good quality information and lots of information is only useful if we can make that available. So in parallel to our science R&D and the focus on sustainability in that sense, we're also working on a big piece of work to try and ensure we develop how information is accessed. And to do that, we have lots of background information and data that we've been describing over the last few minutes, but we're also building a series of capabilities. So, for example, gridded data sets, subsets of those gridded data sets, so whether that's a global, whether that's a regional area, but also such as 4D trajectories or corridors of information, or, for example, things like web map services, so they can be used to visualize, for example, on an electronic flight bag or on another visualization system. So a big piece of work really is how we develop data services utilizing modern capabilities to really get access to those relevant data sets. And a good example of that, I think, really is if you were to imagine the atmosphere of a series of gridded boxes and an aircraft flying through those. What we're trying to enable the access to is the relevant information for that application. So whether that's a 4D trajectory, whether it's a corridor, what is the right information what is the relevant information for that specific application? Because of course, moving large chunks of data around the world, and they're increasingly massive, the amounts of data we're moving around given the high resolution capabilities, there is a carbon cost to that in sending lots of data. So what we're trying to do is enable access to those small amounts of data that are relevant for the application. And these two areas are working in parallel over the next coming months and of course years. So with that, I'll hand back to Alex, and thank you.
Thank you very much, Jonathan. Fascinating stuff. Just again, a reminder, if you do have any questions, if Jonathan's presentation there has sparked a question or a query, please do just fill it in the queue of the question box there, and we'll get to those questions at the end. So we've heard from the Met Office, we've heard from the weather and the data point of view. Now let's get a point of view from AVTECH and the company behind the software that's done this particular bit of software development for the aviation industry. And for that, we can head to Stockholm, where we're joined by Nicholas Persons. Nicholas, take it away.
Thank you, Alex. Not only would I like to start to thank Met Office for hosting this webinar, I also would like to thank you all for taking time and joining us here today. I'm also glad to see that there is such a big interest in this topic, making aviation greener and how we already today can minimize the emissions from each individual flight, and also contributing to more sustainable recovery for the aviation industry. I also would like to highlight that what you will see today is a great example of how collaboration between companies with different competences, specialized in different fields, can lead to state-of-the-art solutions delivered directly to the industry. So AVTECH has worked together with Met Office now for about 10 years with great success, utilizing the global high resolution weather in different solutions and making it available to the aviation industry. A very short background about AVTECH as a company. We are a Swedish-based company with a history of over 25 years working within the aviation industry. It all started out as a research company. We were involved in several global projects around the world at the time, with a focus on improving the efficiency of the air traffic management system. Having said that, today we are an IT company specialized in delivering services to the aviation industry, and we have a main focus on fuel saving, optimization, and information. And during this transformation from being a research company to become a provider of services, we soon realized that not only is it important to have great solutions, but it's also essential for us to have precise and accurate weather data input into our services. And this is when we started our collaboration with the Met Office. So what I will focus on today is on how we have integrated the high resolution weather in our ClearPath service that has been developed in collaboration both with the Met Office, but also with Norwegian being the launch customer. And for us, it's really important to work closely with the end users, making sure and guarantee that we always maximize the value of the services that we provide. Now, why is it important to have access to the high resolution weather forecast, and what are the challenges for the pilots today trying to optimize the flights? To be able to fly as efficient as possible, there are several factors that will affect the flight, such as the weight of the aircraft, but also the speed at which the aircraft will operate. As a rule of thumb, one could say, and this is really simplifying things as well, but one could say that the lighter the aircraft, the higher is the optimum level at which the aircraft should operate and should fly to minimize its fuel consumption. Now, this would be true if it wasn't for the fact that flying an aircraft means operating in an ever-changing and dynamic environment where weather has a great impact on the actual performance of the specific flight. So both the temperature, but more importantly, the winds needs to be considered when we try to optimize the levels at which, or at the levels at which each individual flight should fly from point A to point B. So if we compare this to driving a car, the wind has a direct impact on the actual speed of the aircraft in relation to the ground. So as a very simple example, let's imagine we have an aircraft flying at 100 knots and we let that aircraft fly in a headwind of 10 knots. It means that the resulting speed over the ground would be 90 knots, and vice versa. If we instead fly an aircraft at 100 knots in a tailwind of 10 knots, the resulting speed over the ground would be 110 knots. Therefore, there will always be a trade-off between the most optimum altitude when it comes to the fuel burn and the actual fuel consumption, and this at a specific level, and the time it takes to fly at that level. And this is where things start to become quite complex. And also when we start to use the high resolution winds, but it's also this that means that we can actually optimize each flight in the best possible way to reduce or minimize the fuel being used for the flight and to reduce the emissions. So now, understanding why high resolution winds and temperatures are so important, let's look at how we utilize this in AVTECH's services. Having a huge set of data, and in this case, high resolution weather data, does not mean that the data by itself add value to the end user. So there are a few challenges here. And there are two major challenges, I would say. The first one is to make sense of the data, and the second one is to be able to use the huge amount of data and deliver it to the end user. So the first challenge, to make sense of the data, we can do that in two ways in our services. We either filter the data and provide the filter data, which is the data required or needed by the end user, and only that data, and we do it at a specific time. The other way we work with the data is that we use a larger set of this huge amount of data. We use it in our services, our ground-based services, compute everything on the ground, and then deliver decision support to the aircraft and to the pilot. So this is the first challenge, making sense of the data. The second challenge is to work with this huge amount of data and to do it in real time as well. So one should remember that transmitting data in real time to an aircraft is still very expensive. So compared to like the normal day use, using a mobile phone, most people don't really think about the data usage on a daily basis. However, working in aviation, every kilobyte counts. So what we have done in our services, we typically reduce this huge amount of data. And when we talk about the high resolution weather model, it's about 1 terabyte of data. And we reduce this to a set of 2.3 kilobyte of data that we deliver to the aircraft and to the pilot. And we do this in like a 2-step process and without compromising on the value of the service that we provide. So focusing on ClearPath, which is this service where we try to optimize the levels at which each individual aircraft should fly. Now, how did we integrate this into our service, the high resolution data provided by Met Office? Well, AVTECH and Met Office have jointly developed an API through which AVTECH can access this data, and we can do it in real time. And using this API to retrieve weather for any specific flight guarantee that we always use not only the latest available data, but we also use the high resolution data with extremely high accuracy, which is really important trying to optimize the flights. Now, the retrieval of the data from the API is based on what we call a 4-dimensional trajectory. So basically, it's a description of how an aircraft will fly from point A to point B, both in space, but also in time. And this trajectory is either something that we can download from the aircraft onboard computer in real time, or we can create it on the ground based on specific parameters that we choose to download from the aircraft. And this depends a little bit on the capability of the aircraft itself. And based on this, as John also mentioned, we extract or retrieve a volume of weather data. It's more like a corridor surrounding this route. We also have developed this API so that we can retrieve different sizes of this volume, depending on the requirements of the individual service. And by doing this, we minimize the data being transferred, but at the same time, we always make sure that we extract no less than data or the data required for each service to deliver maximum value to the end user. So the result from this is that we in real time can work with this high resolution data down to a resolution of 10 kilometers, and also meaning that the data that we retrieve for each specific flight is tailored for that flight as well in time, which is highly important. So from the video, I hope that you remember that ClearPath tries always to optimize the flight level at which the flight should operate. And this flow shows how we have implemented this into ClearPath and how we actually utilize the data in real time and provide value to the customer, meaning that they can fly their aircraft, minimizing the fuel in the most optimum way, and in the very end, reduce their environmental footprint. So the first step to do this is that we communicate with every aircraft in real time, and we do it on the ground when the aircraft is on the ground or when they are in the air. And we do this to retrieve the actual parameters of that flight. And with those parameters, we create this trajectory that I mentioned before, the 4-dimensional trajectory. We send this to the Met Office, and back is this volume of weather data that we retrieve. Now, as I mentioned earlier as well, we use this in ground-based systems, and this allows us to work with bigger amount of data sets, both when it comes to the high resolution weather, but also when it comes to the performance models of the aircraft that we use. And also using much larger computer power, which is available on the ground, means that we can have very, very short response times to our services. Then in the very end, and which is really important then, is the result. So the result from this optimization is then delivered in real time to the pilot. And what the pilot will get is decision support stating exactly along the route where they will either climb or descend and to which level to fly the most optimal flight path. And the pilot also gets direct feedback on how much fuel this will save if they fly this optimum route and following the instructions they get from ClearPath. As mentioned before, this is a service that we developed in close collaboration with Norwegian, our launch customer. And after we have developed the service and implemented it in their Boeing 737 operations, we ran an analysis for 3 months, which meant that we ended up doing this analysis for approximately 34,000 flights. And the outcome and the result is that we can see that on average already today we can have a potential fuel saving of 1.6% of the cruise fuel being used for each individual flight. And this quite rapidly starts to add up. So if you think about 1.6% and the fact that each flight uses a couple of tons of fuel, and then you also multiply this with the number of flights, you get quite significant results, and which in the very end then has a very, very great impact on the fact that we in real time already today can reduce the fuel burn and reduce and minimize the emissions from each individual flight. And with those words, I would like to hand back to Alex.
Thanks very much, Nicholas. Absolutely fascinating stuff there. Really good, incredible numbers. Really, what you say when you start multiplying them by the number of flights. So yes, very impressive stuff. Excellent. We're a little bit early actually, so we've now got 20 minutes time for Q&A, so that's good. So there is still time to get a question in. Use the Q&A facility if you can. If you have a burning question or a query for Nicholas, or for Jonathan, or indeed for our final guest who's here to answer some questions as well from Norwegian. We have Anders Fagernes is joining us as well. So yes, we've got 3 people here who are able to take your questions if you do have them in the last 20 minutes or so. Let's introduce our final guest though from Norwegian. Anders is joining us. Anders, I introduced you very briefly at the start, but if you could just say a little bit perhaps about your role and your interaction with the Met Office and with AVTECH, that would be really useful before we get into the questions.
Yes, thank you, and thank you for a great presentation, both from John and from Nicholas. Well, I think I would like to use the opportunity to take a little bit step back and look at it from my perspective. This great example, it shows how people really are at the heart of any, I think, environmental sustainability strategy, and particularly for us here. It shows great coordination across different companies, but if you look at it from our perspective, it also requires a lot of coordination internally. So we have our pilots, and what we try to do from our service office here at Fornebu is to give them and provide them with the best available technology that reduces emissions today. AVTECH is one. Another example is our cooperation with Open Airlines and the Skybreathe app. Then we also rely heavily on our flight planners to calculate the optimum route plan to ensure an efficient and smooth flight. Also, the maintenance and engineering teams, they need to ensure that the aircraft are performing at the optimum level. And finally, our data analysts review our flights to find whether they can improve any more. So I think there is really, you know, when you start getting into the details, you can see how much the expertise and the competence from various parts comes together to create this fantastic result.
Thanks very much for that, Anders. Okay, let's get into some questions. We've had some coming in already. First one, perhaps for you, Nicholas, if you don't mind. This one is about the trade-off. So a question about the AVTECH methodology. Does the trade-off between time and fuel saving take into account the additional fuel burn to climb to a new altitude? Would the model keep the aircraft at the same flight level if the time/fuel saved by the climb is equal to the fuel burned? Does that make sense to you? Are you happy to answer that question?
Yeah, sure, it does make sense. And yes, the short answer is yes, it does. So we always optimize from point A to B, taking everything into consideration. So we calculate the fuel burn to climb to specific levels, also the reduction of the fuel burn if you descend to other levels and so on. And there is always this trade-off between time, fuel being used. So basically what we produce here is a total cost optimal flight path. So everything is taken into consideration. So it's not that we climb with a fuel burn of 0. So we definitely take that into consideration. It's all included.
Okay, great. Thank you for that. Question for you then, Anders, perhaps a more general question here. Just what do you see as the key success factor to make aviation more sustainable? Where does Norwegian stand on that? What is the key success factor?
I think I would like to sort of relate back to what I said earlier, that it's about getting the people, our employees, and everyone, really, all hands, all heads, all feet on deck at this quest. We have, I mean, if you look at a normal day in an aviation industry, it's a lot of stress. It's quite stressful. It's a lot of things, small things to take into consideration. And 10 years from now seems a very long time. But as Met Office, you have set your target to net zero in 2030, and in order to reach that, I think we need to start making the decisions today. We need that data from you guys to make those good decisions and really put the actions into place that we have, the levers that we can pull. We need to pull them today.
Thanks for that, Anders. Okay, let's have a question for John now. John, what about the accuracy prediction of regions of air that are super saturated with respect to ice? So a proper Met question here. How accurately can these be predicted?
Okay, thanks, Alex. And yeah, it's a good question. I'll do my best to answer that. So we have recently actually developed an updated algorithm for in-flight icing. Based on our work primarily around the World Area Forecast system. And that has now taken into account several different factors around icing, including temperature, vertical velocity, and liquid water content in the atmosphere. That algorithm we're now using is significantly more sophisticated than its predecessor, and we do have some initial verification of that, and the indications are that it does quite a good job in predicting areas of airframe icing. I should say, of course, that the verification of icing is to some extent a challenge, given it's difficult really to get hold of when aircraft icing is encountered, and naturally being a hazard, people tend to avoid areas of severe icing in the first place. So, but nonetheless, we have also taken part in some field studies with research aircraft to look at this, and that gives us some of that confidence around the good verification I think we'll see from that algorithm we've now got in place.
Thanks for that, John. Really good. Okay, moving on to another question now for Niklas. Perhaps why are you only varying altitude, and what does ATM have to say about altitude changes?
So really 2 questions there. So the first version of ClearPath is a vertical optimization, basically optimizing the flight levels. But what we are doing at the same time now, developing a horizontal optimizer as well. So this is something that we're looking into, and that will be a feature in the future for this service as well. And the second question there, when it comes to air traffic control and what they have to say about altitude changes. So we are well aware about the fact that sometimes you cannot change altitude and sometimes you can. But what we do here with this is that we always try to provide the pilot with the best decision support so they can negotiate other levels than planned in the flight plan. So there are sometimes restrictions in the flight plan when you actually file a flight, and those might be restrictions due to the city pair you're flying in between. There might be national restrictions flying domestic flights and so on, but there might also be other restrictions like extremely busy airspaces, which means that you just for operational purposes you file the flight plan at a lower level that you also know at the time is not the optimal level. So what we do with ClearPath is that we always try to support the pilot and give them the best possible decision support, meaning that they can at any time throughout the flight negotiate with ATC to fly different levels compared to those being filed in the flight plan. And this is something that is happening every day using optimization services and also not using optimization services, pilots will try to fly direct routing when it comes to the horizontal plane, and also they will try to negotiate different levels. So this is something that is negotiated in between the pilot and air traffic control.
Okay, thanks for that. Let's move on to another question now for Anders. Again, quite a broad one, this, but what is the relationship at Norwegian between sustainability, obviously where your area of expertise, but also having to make a profit and profitability? So how is that? How do you find that balance between sustainability and profitability at Norwegian?
Thank you. It's a really good question, and I think what this example with AVTECH and Met Office data shows is that when profitability becomes part of the equation, so for us, fuel saving goes hand in hand with the saving CO2 emissions, then you can really start to scale it. So profitability is really economic profitability is really a key for us to succeed. I think what we're looking at very closely as well, where UK has taken the lead, is sustainable aviation fuels. Well, we've worked on that for a long time. The big issue is that it's not profitable. It's really expensive. But here you can see real solutions that also provides a profit. It's difficult to implement, but when we do, we get something in return on the bottom line.
Okay. John, now a quick question here about the fuel savings in particular. Are the fuel savings observed mainly from the different wind patterns or the efficiency of turbulence avoidance? What's the relationship between those two?
Okay, thanks, Alex. And as Nicholas may like to comment on this also, but I think the information, the figures provided in the video were based on the wind and the efficient routing based on wind information and forecast. So we would anticipate the additional savings, if you like, from effective use of, for example, the turbulence fields or the icing or the CB and thunderstorm information as well. So the figures are in the study, and the bulk of the figures we have at the moment in terms of savings are based on wind, and I think there's more to do on the hazards. But I see Anders may like to comment also on that.
Yes, this is on the winds, and as previously noted, it's also dependent on continuous improvement because it's a potential, and the potential needs to be used every single time we fly. So I just wanted to make that note. Maybe Nicholas, you have something to add?
No, I just agree. I don't really have anything to add to that. That's exactly how it is.
Okay, good stuff. That's cleared that up. Thank you. Another question for you now, then, Nicholas. Can ClearPath update dynamically based on current conditions? So, if wind direction or speed was slightly different in reality to what the model was saying, can they adjust the flight route or level? How dynamic is the system? So it's very dynamic. So it can be set up to run automatically and manually, or a combination of these, meaning that the service is dynamic. It will always be available throughout the flight and even prior to takeoff as well, on the ground before they actually take off, meaning that it can be used during the initialization of the flight as well. So as things changes throughout the flight, when it comes to weather, when it comes to the routing, like rerouting, you get directs, there might be other constraints and so on. The weight of the aircraft changes due to the fact that you didn't get as much cargo or as much passenger as expected before takeoff. You can always request an update from our service, and it will also run automatically at predefined points throughout the flight. So it's totally dynamic, and the most optimal flight path can always be calculated based on new conditions throughout the flight as well. Excellent. John, this is an interesting question about a historical bit of science that's been done. previous Met Office study published by Lunnen and Merzer, apologies for the pronunciation on that, found essentially no benefits from high resolution wind data. There was a 1 second flight time save and an 8-hour flight. So how do we reconcile these new data results with that previous study? Are you aware of that study, John?
Yeah. Thanks. And we are aware of that study, and I think I'm right in saying that was a 2007 paper. And that was, again, if my recollection is correct, that was based on 160 kilometer global data. So of course things have moved on both in our global modeling sense since that time, and also moved on in technology sense in terms of how data can be interrogated and used for specific flight applications since that paper was written. The capability now, of course, is moved up to 10 kilometer horizontal data. In addition to that, there's also significant steps in global modeling capability to allow much more frequent time steps and also vertical levels as well. So I think that data, that paper at the time was based on the capabilities of global data that was available then. Things have moved on an awful lot since then, and I think some of the figures that we've seen today show a significant change from that in terms of there being significant benefits now to utilising high resolution data. I don't know whether Anders or Nicholas would like to comment on that also.
I would just like to, I spoke with one of our chief pilots the other day, and he just said to me, Anders, it's extraordinary, the accuracy of the data that we get. So I think when you start getting to this level of detail, and it really becomes, fun and exciting for our pilots as well. So maybe that can have something to do with it.
Yeah, excellent. Okay. Another question for you now, Nicholas, about net zero, and particularly with military aircraft. RAF chiefs and air staff have stated that they want to be net zero by 2040. What do military aircraft need to implement to be able to use this system? How easy is it for them to get hold of this system?
Yeah, so the way we have set up all our services is that we build them in a way so that they should be available to an airline today using existing technology, meaning that there will be no investments to get started to use our services. And the same is applicable to RAF. So basically our service is set up in a way that it uses standard communication with the aircraft, with existing hardware on board the aircraft, and everything is more or less already set up to start the service. So basically we do some modifications on our side, but for the customer, it's straightforward, and it uses already existing technology.
Great, thanks very much for that. Let's go back to Anders now, and again a more sort of broad picture about environmental sustainability here, and how Norwegian, how do you, there's so much going on in this space at the moment in terms of public demand for being more environmentally friendly, but also trying to reduce the amount of flights that we use as well. So what actions do Norwegian prioritize to implement the environmental sustainability strategy? How do you go about prioritizing those things? Because there must be so much you could do and so many options.
Yeah, it is a big task of getting the full picture, and as you say, you need to contrast and compare the different levers. Well, to say it very broadly, we have the biggest bulk is really renewing our fleet and buying the newest, most modern aircraft, and with improved engine technology. The second is sustainable aviation fuels, and the third is operational efficiency. We have, over a period from 2010 to pre-COVID 2019, we invested heavily in new aircraft, and that reduced our CO2 emissions measured as grams of CO2 per passenger kilometer with 28%. We've set ourselves a quite bold target to have an additional 24% by 2030. And the job right now is really to create as much predictability as possible into the variables. So on the one side, the market variables, and on the other side, the regulatory variables, in order to figure out the most cost-efficient way to achieve that target. And to be honest, it's that answer is still in the air.
ongoing, I think. A big challenge for everyone concerned. Okay, another good question here for you, John, about AMDAR in particular. Can you comment on how aircraft-based observations, aka AMDAR, from airline partners provides a benefit to the accuracy of these high-res models? It's kind of a positive feedback loop, I guess, and how that impacts on this work.
Yeah, thanks. And again, a good question, I think, because the AMDAR information and the aircraft observations really provide a real key input into our modelling processes. So we assimilate that AMDAR information, the wind and temperature information particularly, for each model run. So all the information collected from aircraft is used in the understanding what the atmosphere is currently doing now, and that helps us provide an accurate prediction going forward. So it's a key input parameter to our forecast process.
Excellent. Okay, just time for perhaps a couple more questions. Do keep them coming in if you've got them. But we are running out of time. But maybe one more question, particularly about safety. I guess this one back to you, Niklas, because we talked a moment ago about the flight path changing dynamically, but doesn't that create a problem potentially with other planes also changing their flight paths dynamically and getting too close to one another? So how do you stop that? How do you maintain safety with this new technology?
Well, so when it comes to safety and when it comes to the separation in between aircraft and separating aircraft from each other, that is something that is handled by air traffic control. So at no time would any aircraft just change level due to the fact that they get like a new optimized level from the clear path of service. Instead, they will use that information to negotiate that with ATC. So there is always a safety issue, but that is handled by air traffic control at all times.
Right, so it doesn't interfere with air traffic control.
No.
Okay, very impressive CO2 savings. This question comes in, but what are these? I guess it's a question for you, John. What percentages are they of the aviation industry's total emissions, and how do these reductions compare to the increase in emissions from the industry's growth? For example, is this a stepping stone with a longer term plan? I guess that kind of ties in with the new supercomputer that the Met Office are getting as well.
Yeah, thanks, Alex. And it's a good question, I think, and it's a I don't have the specific stats in terms of the total carbon footprint from aviation, of course, but I think in the video it showed a figure of 1.6% being saved for the en route phase of flights. So in addition to that, and you could of course extrapolate that up through all of the different flights operating, but in addition to that also would be the descent, the climb phase, and of course activities such as on-ground taxiing as well to provide a saving. So I think from a Met Office perspective, the saving is part of what weather information can do to contribute to that overall approach, and of course the wide range of information and activities going on for a more sustainable approach. This forms part of it, and I think overall I remember seeing a stat recently whereby between I think it's 2012 2016, whilst UK passenger numbers has gone up by 25%, I think the actual carbon emissions had only increased by 5% or so. So within the wide scheme of activities within the industry, this forms part of that, I think, and we recognise that. In terms of the steps, if you like, onto what we can do, as you just mentioned, Alex, the supercomputer investment and development we've got underway really enables us to continue to develop that process of providing higher detailed, higher accuracy information, both in a horizontal, vertical, but also time resolution sense as well. And therefore we see though that potentially increasing the ability to offer that increasingly efficient and therefore sustainable approach to the information we can provide. So I hope that answers the question as far as we can for now.
That's brilliant. Thank you very much, John. Yes, I think that does answer that question, and thank you for answering all of those questions. That is pretty much it. 3 o'clock, 1 minute past 3 here in the UK. Thank you very much for all your questions, for your involvement. Thank you for listening as well, and being here. Very sorry if we didn't get round to answering your questions, but if you do have further questions, you can still get in touch with the Met Office. aviation@metoffice.gov.uk is the best way to do that via email. A big thank you as well to all our panel, to Nicholas, to Anders, and to John. If you've enjoyed this webinar, then there is another one tomorrow. This is on the broader picture for business. That's at 1 o'clock UK time. Join us for climate risks and opportunities for business leaders. And you can find out how to join that if you follow the Met Office on LinkedIn. Make sure you're following us on LinkedIn as well for all the latest aviation developments on there, and also make sure you're following the Met Office on Twitter, whether that's our main feed, Met Office, @Met or the B2B, the business account @Met Office B2B. There's loads more information on the Met Office website as well. All this information will be coming up in the end screen in just a second also. So there's a website where you can go to. The Met Office has lots of information on there. And please do fill in the questionnaire if you've enjoyed this webinar, or if you've not. Any kind of feedback is always very welcome. If it will just take you 5 minutes to fill that in, and we would really appreciate that. So that is, as I say, just about it from us. All this information will be coming up on the final panel in just a second, but just one more big thanks to all our guests today, and thank you for your participation. But from the Met Office headquarters in Exeter in Devon, it's goodbye and thank you.